Hello students, I am solving chapter number 1 chemical reactions and equation for class 10 science, and in this video I am going to solve NCERT exercise or the questions present in exercise which is there on page number 14. Already I have explained whole chapter in detail, and also I have solved the questions which are present in between the chapter and already uploaded those all the videos on my channel. Go through my channel, watch my videos, and if you like, please consider subscribing my channel. Now I'm going to start with question number 1, that is from NCERT exercise chapter number 1 chemical reaction and equation, page number 14. So question number 1 is, which of the statements about the reaction below are incorrect? So this is the reaction which is given, and according to this reaction we have 4 statements. So see the reaction first. 2PbO plus C gives 2Pb plus CO2. So for this reaction the statements are: statement 1, lead is getting reduced. Second statement, carbon dioxide is getting oxidized. Third statement, carbon is getting oxidized. And fourth statement is lead oxide is getting reduced. So these are the 4 statements which are given. And here there are options. Option number A and B means A and B both are incorrect. Option number B, second is A and C means A and C both are incorrect. Option number third is A, B, C. A, B, C. All 3 statements are incorrect. And option number fourth is all means all are incorrect. What do you mean by incorrect? Incorrect means which is not correct. Now here I have written the answer. So let me explain first how I have got this answer. Before explaining what is oxidation and what is reduction, this we should know here. So oxidation means what? Addition of oxygen. So I'll write here addition of oxygen is called oxidation. And what is reduction? Reduction means it is addition of hydrogen. So this is the definition of oxidation and reduction. Or in the other term we can write here addition of oxygen or removal of hydrogen. Like this also we can explain what is oxidation. And for reduction, addition of hydrogen or removal of oxygen. So these are the definitions of oxidation and reduction. Now we will apply these 2 definitions to the reaction. So let me write the reaction once again. So PbO plus C gives 2Pb plus CO2. So here you can see this is the reaction which is given to us. Now see, if you see this reaction, this side is called reactant and this side is called product. So let me correct it. Here I have written little bit of wrong. So now I have corrected. I have written here 2Pb, and as I was telling, these all are product. So when the reaction says who is undergoing oxidation and reduction, remember we have to search for reactant side. Now see, according to the reaction, PbO becomes Pb, means from PbO oxygen is removed. It was PbO and now it is Pb, so oxygen is removed. So what is oxygen is removed? So you can see the definition: when removal of oxygen occurs, it undergoes reduction. So means it has undergone reduction. Then if we see carbon, it was C and now it became CO2. So oxygen is added, and addition of oxygen is called as what? Oxidation. Oxidation. So this is the correct way to answer this. So according to the reaction, according to the definition, in this reaction PbO is undergoing reduction and carbon is undergoing oxidation. Now we will see our option. Lead is getting reduced. Lead is getting reduced. But here if you see at the reactant side, there is no lead. Lead is on the product side. So lead will not undergo reduction. Remember, lead is present on the product side, so it will not undergo reduction. So this is the incorrect statement. They have asked incorrect, no, wrong statement. So this is the wrong statement. Second one is carbon dioxide is getting oxidized. So where is carbon dioxide? Carbon dioxide is again on the right hand side. So this is not undergoing any oxidation process. Remember, because it is present on the product side. So that's why this is also an incorrect sentence. Now if you say C, carbon is getting oxidized. This is carbon. It is undergoing oxidation and becoming CO2. So this statement is correct. Carbon is getting oxidized. According to the answer point of view, this statement is correct. But according to this question, this statement is incorrect. Sorry, it is wrong one. Now see here, option D, that is statement D, lead oxide is getting reduced. Where is lead oxide? Here. And this is getting reduced. Yes, it is undergoing reduction. It is getting Pb. So this statement is exactly correct. But we want incorrect. That's why this also we are not going to consider. So incorrect or the long statements are A and B. Now we have to search for the option. If you see the option, Option 1 is A and B, option 2 is A and C, option 3 is A, B, C, and option 4 is all. So according to our explanation, A and B both are incorrect, which is according to this question, it is correct. So A and B we have to search, and A and B is the first option. That's why option 1 is the correct one. So answer, incorrect option is first one, that is A and B. So this is the answer for question number 1. Now we will move with question number 2. Question number 2 is Fe2O3 plus 2Al gives Al2O3 plus 2Fe. This is the reaction which is given. The above reaction is an example of. So if you see the chapter, we have studied a type of reactions. We have studied combination reaction, decomposition reaction, displacement reaction, double displacement reaction, etc. So we have to find out the given reaction is of which type. So the options are combination reaction, double displacement reaction, decomposition reaction, and displacement reaction. Here the option is what? Option D, that is displacement reaction. Let me explain with the help of equation. So see here, Fe2O3 plus 2Al gives Al2O3 plus 2Fe. This is the reaction which is given. And if you see this reaction, you can understand this is one reactant, and this is a second reactant. Now, the second reactant is going, the whole second reactant is going and displacing part of the first reactant. Remember, the whole second reactant is going and displacing the part of the first reactant, only the part, not whole. So Fe2O3 means whole, and out of Fe2O3 only Fe, it is called as part. So whenever part of one reactant is replaced by the other reactant, such reaction is called as displacement reactant. So I'll write it here. Part of one reactant is displaced by other reactant. Other reactant is called displacement reaction. So what is displacement reaction? When part of one reactant is replaced by the other reactant is called displacement reaction. So if you see the reaction, part of this first reactant, it is getting displaced by second reactant. That's why it is the example of displacement reaction. So option D, displacement reaction. I hope you will understand the explanation. Now I'll move with next question. Now the question number 3, what happens when dilute hydrochloric acid is added to iron fillings? Tick the correct answer. So whenever we are going to mix dilute hydrochloric acid to iron fillings, what is going to form? What will happen? We have to tick the correct answer. Options are A, hydrogen gas and iron chloride are produced. Option B, chlorine gas and iron hydroxide are produced. Option C, no reaction takes place. And option D, iron, salt and water are produced. So here the correct answer is option A. Let me explain it with the help of reaction. So we are going to take iron fillings, which is solid, and we are going to mix with the dilute hydrochloric acid, HCl. Dilute means, I can write it here, AQ. Dilute means what? Water will be added. So it is said as aqueous solution. When these two are reacted, here this is metal and here this is acid. So whenever metal reacts with acid, it gives salt and hydrogen gas. It gives salt and hydrogen gas. So how we are going to get the salt? When this metal electropositive combines with the non-metal electronegative, we are going to get a salt which is called as FeCl2, iron chloride. And what is remaining? The remaining is here H2, and that's why I'm going to get here hydrogen gas. So this is the product which are going to get in this reaction. So what are my products? It is iron chloride and hydrogen gas, and that's why if you see all the options, the first option is hydrogen gas and iron chloride has produced, which is the correct one. That's why the answer is option A. Now we'll move to the next question. Now the question number 4 is, what is a balanced chemical reaction? Why should a chemical reaction be balanced? So always remember, whatever chemical reactions we can see in our day-to-day life, all should be balanced. And why it should be balanced? This we have to answer. So the answer is, a balanced chemical equation consists of the total number of moles of elements in the reactant and that in the products. So remember, what is balanced chemical equation? It is nothing but which is having equal number of moles of reactant and equal number of moles of product. Means the number of atoms present on the left hand side, reactant side, must be equal to the number of atoms present on the right hand side. So in general, if you see any reaction, A plus B gives C plus D. So these are called reactant and these are called product. So now we have to calculate the number of reactant and product. How many reactant we have? 1. Here also there is a 1. 1 plus 1 is 2. How many products we have? 1. And this is also 1. So 1 plus 1 will be 2. So if it is equal, number of reactant, number of product, if it is equal, then the reaction is called as balanced chemical equation. Now, why we have to study this? Why we have to do this? According to law of mass of conservation, chemical equation should be balanced. The law states that mass can neither be created nor can be destroyed. So always remember, whatever you can see in the universe, whatever you can see beside us, whatever reactions we can see beside us, it may be man-made or it may be a naturally made reaction. Always remember the number of reactants and the number of product will be same, equal. And this is given by the law which is called as law of mass of conservation, which says that mass can neither be created nor destroyed. Whatever number of reactant you have, same number of products you are going to get. Products will be different compared to the reactant, but the number of atoms in the left hand side will be always equal to the number of atoms on the right hand side. And this is only called as law of mass of conservation. And because of this law, because of this statement only, therefore, in a chemical reaction, the total mass of a reactant should be equal to the total mass of the product. Nothing will get waste. Everything will convert from one form to another form. So here A is one chemical and which may be have converted into C or D. B is one chemical which may be have converted into C or D, or C or D may be the mixtures of these both. But no little amount of reactant or no little amount of product will get waste. So this is about the question number 4. Now we will move to the next. Now question number 5. Translate the following statements into chemical reactions and then balance them. So here they have given some of the statements like this: A, B, C and D. These statements we have to convert into chemical equation by using their formulas, and once we convert, then we have to balance it. Number of atoms left hand side, number of atoms right hand side should be equal. That we have to do it. So the first one is statement: hydrogen gas combines with nitrogen to form ammonia. So what is hydrogen? Hydrogen is H2. What is nitrogen? Nitrogen is N2. And what we are going to get? We are going to get ammonia. The formula of ammonia is NH3. So I wrote it here, NH3. Now, if you see this reaction, it is not balanced. This side, Nr2, HR3. But on the right hand side, N is only 1 and HR3. So this we have to balance it. And for balancing, we have to use a trial error method, or you can make columns and balance. Remember one thing, you have to practice many reactions to know how to balance the equations. Already I have explained these all the methods how to balance in my earlier videos. You can go through my channel. Now see here, how many nitrogens we have here? Hydrogens we have 2. How many nitrogens we have? 2. But here the nitrogen is only 1. That's why I will write a coefficient 2 here. When I write 2 on the right hand side, nitrogen becomes 2, but hydrogen will become 6 now. 2, 3 are 6. And to balance this side we can write it as 3. So see what happens now. 3 2s are 6. This is also 6. This balance. This is 2. Nitrogen also 2. So this is also balanced. And that's why the balanced chemical equation is this one. 3H2 gaseous state plus N2 gaseous state, and we are going to get ammonia, that is NH3. This is the answer for first one. Second one, hydrogen sulfide gas burns in air to give water and sulfur dioxide. So see here, hydrogen sulfide H2S burns, means react with oxygen, gives water and sulfur dioxide. Water is H2O and sulfur dioxide is what? SO2. So I wrote it here SO2. This is already a balanced equation because already I have written it as an answer. How to balance it? Let me show it on the other side. So let me write that reaction once again. So I'll write H2S as it is without writing its coefficient. I'll write it here oxygen. Here I'll write H2O and here I'll write SO2. Now we have to balance this whole equation. Now see, during balancing you have to calculate all the atoms. Hydrogen how many here? 2. Here hydrogen 2. Oxygen how many here? 2. But here oxygens are 3. This is 1 and this is here 2. So total it became 3. And to balance the oxygen, I'll write it here 3 now. If I write 1, it will be only O2. If I write 2, it will be 2 to the 4. If I write 3, it became 3 2s are 6. So oxygens are how many here? 6 now. But if you see on the product side, oxygens are still 3 only. So we have to make this also to the 6th level. So now what I'm going to do, I will write it here 2. So when I write it 2, 2 2s are 4, and 4 plus 1 will be 6. So oxygen is balanced from here as well as on the left hand side. Now if you see, once I wrote it here 2 on the SO2 side, S also has got changed. S became 2. And to balance this, I should write it here also 2. So now S is also balanced. What about hydrogen? But hydrogen here it became 4. And this side hydrogens are only 2. So this also has to be balanced. So to make it 4, I wrote it here 2. So 2 2s are 4. So this also became 4. 4 and 4. Now if you focus the reaction and see how many numbers of atoms are present on left hand side and right hand side, you will understand the reaction is balanced or no. Let me clean it and write it properly. So I'll write it here. Hydrogens, how many we have? 4. This side hydrogens are 4. Okay, it is balanced. Next, sulfur, how many here? 2. This side how many sulfur we have? 2. So this is also balanced. Now see oxygen, how many oxygen? 6. And this side how many? Here it is 2 and here it is 4. And that's why 2 and 4 will become again 6. That's why this 6 and this 6 also balanced. And that's why the reaction is balanced. This is the way to balance the reaction. Now we will see the C. Barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. First we should know the formulas of all. Barium chloride formula is BaCl2. Then aluminum sulfate formula is Al2SO4 thrice. Then aluminum chloride formula is AlCl3 and barium sulfate formula is BaSO4. You should know how to write this formula, and to know these formulas, first we should know their oxidation states, their valency. As I'll tell you one, Al has oxidation state +3, Cl has oxidation state -1, and that's why when you cross it, here it will become AlCl3 because this 3 will come down, this 1 will go here. So AlCl3, so this is the formula of aluminum chloride. So we should know how to prepare the molecular formulas or directly remember the molecular formulas. Now start balancing this reaction. So let me clean the page once again. So I'll write the reaction once again. BaCl2 plus Al2SO4 then thrice, and it gives AlCl3 plus BaSO4. Now we will start balancing the equation. Now see here, if you focus this whole reaction, here how many Cl we have here? Cl we have 3. Ba we have 1. Here also we have 1. So Cl we will balance first. So you see here 2 Cl and here it is 3 Cl. So 2 and 3, whenever number comes to balance, this Cl multiply by 3. So it becomes how many? 6. This Cl multiply by 2, it becomes how many? 6. So same method we are going to use on both the side. And that's why start balancing first this Cl. So to balance this Cl, I'll write it here 2 and this side here write it 3. See here. 3 2s are 6 and 2 3s are 6. When I wrote here 2 aluminum, now we have to check for aluminum. Aluminum is already Al2, so it is balanced. Now, if you see Ba it is 3 here, but on the right hand side Ba is only 1. So I'll write it here 3. When I write here 3 for Ba, S is changing. S became 3 and O became 4. Sorry, 3 4s are how many? 12. And this S became 3. Now see on the other side here, this 3 which is there outside the bracket, it is applied for both this S and O. So S is already 3 and O is already how many? 12. And now if you see on the other side, we want the same thing. Yes, we want 3 and O we want 12. So it is 12 and 3. Done, balanced. So that's why the balanced chemical equation is 3BaCl2, Al2SO4 thrice, 2AlCl3 and 3BaSO4. This is the balanced equation. And remember the bracket, whatever it is written, these are the physical states. It may be solid, liquid, gaseous or aqueous. If you write these physical states and balance the equation, then it will be exactly a correct balanced equation. Now we will move with the next one, that is fourth one. Potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So we are going to take potassium metal K, react with water, so H2O, and we are going to get potassium hydroxide, that is KOH, and hydrogen gas. So let me write the reaction first and then we will see how to balance it. So write down the reaction once again. K plus H2O gives KOH plus H2. So this is the reaction which is without balancing. Here already I have written the balanced equation, but let me show you how to balance it. Now see here, how many H2 hydrogen here? 2. How many oxygen here? 1. How many K here? 1. This side how many K? 1. Oxygens how many? 1. But hydrogens total how many? 3. So now we have to balance hydrogen first. So to make it equal, what we have to do, I'll write it here 2. When I write it here 2, hydrogen became 4, oxygen became 2. But this side still oxygen is 1. To make it 2, I'll write it here 2. Oxygen became 2. Potassium also became 2. Hydrogen, it is correct, it became 4. Now we have to balance potassium also. So I'll write it here 2. So this also will become 2. Now see 2, 2 balanced, 4, 4 balanced, 2 and 2 also balanced. And that's why the chemical reaction which is balanced is 2K plus 2H2O gives 2KOH plus H2. And these are their physical states: solid, liquid, aqueous and gaseous. What do you mean by aqueous? Aqueous means it is present in water, dissolved form, that is called as aqueous. So this is the method how to balance the chemical reaction. If you practice the reaction, it will be easy to balance any type of reaction. So try to write the reaction first and then try to balance it by your own. Practice it first. And after practicing, then you see the correct answer. So it will help you to solve or balance any type of reaction. So this was the answer for question number 5. I hope you will understand these all the answers because I have explained in a very simple and the neat way. So if you like my videos, share my videos with your friends, and if you're not yet subscribed my channel, please consider subscribing my channel. Thank you so much.